Hey guys, welcome to my channel. This is where we go over high school math and physics problems. And today we're going to be going over a review of factoring, which is in the grade 10 math curriculum here in Canada. If you guys like this content and you'd like to see more of it, I'd really appreciate you guys liking and subscribing to the channel so I can help grow the channel to reach more students. So, like I said, we're going to be going over factoring. And more specifically, we're going to talk about the greatest common factor, which is right here, which is also known as a GCF. We're going to be going over factor by grouping, trinomials, which of the form ax squared plus bx plus c. And there's kind of two cases for trinomials. One where a is equal to 1. So this case right here, where this term, this a, is equal to 1. And another case where a does not equal 1. So again, this a is now not equal to 1. And they're very similar. We just have to do kind of an extra step for the case where it's not equal to 1. And then we're going to go over kind of special patterns. And special patterns are really helpful. They're exactly like a trinomial. Like if you see this whole term here, all the way ax squared plus bx plus c, that is similar to this form right here. Ax squared plus 2ab plus b squared. So it's just the variables that are a little bit different. But they're all trinomials. These patterns are all kind of trinomials. Because they have 3 terms except for the difference of squares here. But this positive perfect square trinomial right here, positive perfect square trinomial, which is denoted by this positive here. And there's also a negative perfect square trinomial, which is denoted by this negative right here. And so what these do is they allow us to kind of solve the problem faster and factor it by seeing the pattern. And then once we realize that, you know, our factored form, or sorry, our expanded form is equivalent to this form right here, we can immediately go to the factored form. Okay, so like I said, let's get started with GCF first. And we'll get started with the question 12x plus 6x squared. And so for greatest common factor, what you're doing is you're listing out all the factors of the coefficients, which are, in this case, 12 here and 6, and you're listing out all of the factors of the variable, which is x, and here is x squared. So if we were to kind of do a quick aside, we could write the factors of 12 would be 1 and 12, then there'd be, okay, well, what was the next? 2 and 6, and then 3 and 4. And we could switch the orders around, of course, but these are all the kind of factors of 12. And we could also do it for 6. And this is just for the coefficients. So 6 would be 1 and 6, and then 2 and 3. So here you're kind of seeing and trying to find what factor out of this column, like out of these two columns, are common to both the 12 and the 6. So in this situation, it's actually the 6 right here, because that's in this situation. So it's in the 12x, and it's also in the 6x squared. Okay, so now we can write this as the greatest common factor because 6 is both a factor of 12 and 6, and it's the largest that's common to both of them. So we can write 6 times, and so it's going to be 6 times something gives us 12x, and that something is 2x. Next we're going to do the 6x squared, so 6 times something gives us 6x squared, and in this case it's just x squared. But now you can see that we factored out the coefficient, which is the greatest common factor. But now there's still another common factor in these variables. So there's an x here and an x squared. And this x squared could be written as x multiplied by x, right? So clearly this x here and this x here are common to each other. So we can factor that out. So we can write 6x times, and then now that this x is removed, it's just going to be left with 2. And then we're going to have plus 6 times something equals x squared, but now we have the x out, so it's going to be x here. So here is now the factored form using the greatest common factor. And the good thing about factoring is you can always check your work, right? So if they said for us to factor this, so factor this expression, I'll write it over here actually. They said, you know, take this 12x squared plus 6x squared, and we'll write factor. Then once we get to our factored form, we can check this by expanding. So we can say expand. And now we're going to go, okay, 6x times 2, well that's going to be 12x. And then 6x, so I'm basically just distributing this 6x in. And then 6x plus, or sorry, 6x times x is going to be positive 6x squared. And if this matches this, then we've factored correctly. Okay, so that was kind of the easy version, and throughout all of these examples, or all of these kind of sections, like greatest common factor, factor by grouping, trinomials, and the special patterns, I'm going to be doing 2 questions. I'm going to do kind of an easy one, and then I'm going to do kind of a harder one. So now we can go over to the harder one. So for the GCF, the harder question is going to be, I'll just do a line right here to separate. So it's going to be 12a squared b, that's not very good, squared, b cubed times c plus 24a cubed b squared c plus 36a squared b c squared. Okay, so it's a little bit more aggressive and a little bit more hairy, but we're going to apply kind of the same principles. We're going to look at the coefficients, which in this case are 12, 24, and 36, and then each of the variables, which are a, b, c, and a, b, c for all of them. So now, we could list out, like we did over here with the factors of 12, we could do something similar to this, but what you can see is that 12, 24, and 36, well, that equals all of our coefficients. So now we know that 12 is a factor of all of them. So we can take the 12 out. And this next step, we could also, or before we kind of just take the 12 out, we could look at some of the variables. So each of these terms has an A term, a B term, and a C term. So we could factor out this A term, this B term, and a C term to get, so now 12, we need to kind of expand this in to get this product. So working backwards, we could say that we have an A term here, because A times A is going to equal A squared, and then a B squared term, because B times B squared is going to be B cubed, and that C term, well, we already factored that out, so we actually don't need to write that C term, because it's just C to the power of 1. You can write C to the power of 1, if that makes it easier. Next, we're going to do a plus, and then 12 times something is 24, so that something is 2. Then we're going to have A times something is going to give us A cubed, that's A squared, and similarly, it's going to be times B, because B times B is B squared, and finally, that C was factored out. And lastly, we have 12 times something is 36, so that's going to be 3. And then we're going to have another A term. That B term is now B to the power of 1, and we already factored that out. So now we're just going to be left with C, because C times C, or C times something is going to go C squared, which is just C. So now that was a great first step, and we've gotten, it looks a lot better now. But we can still see that in this expression, or inside the bracket, we do have a common term still. We have this A term here. So we can actually factor out now another A, which is going to give us on the outside of the bracket 12A squared BC. And then in the inside, we're going to have B squared, because we factored that A out, plus 2AB plus, and then what are we going to have? 3C. Okay, so now looking at this, let's see if there's any common factors in the expression in the bracket. So we have a B squared, we have a B here, but we don't have no B in this 3C term. So this would be the fully factored form using the greatest common factor of a little bit of a harder example. Okay, so now we're going to move over to factor by grouping. I can write factor by grouping. So here, this problem, we're going to start with 2x squared plus 6y plus 4x plus 3xy. So looking at this, factor by grouping is kind of adding another tool of factoring to your kind of math toolbox. So if we look at this entire expression here, there isn't really a common factor to all of them. The coefficients, there's a 2, 6, 4, and a 3. So, if we were to do 3 and 6, or like 3 would go into 6 and 3 would go into 3, but it wouldn't go into 4 or 2. And similarly, if we were going to go with 2, well, yeah, 2 would go into 2, 4, and 6, but it doesn't go into 3 evenly. And then if we look at the variables, we also see that there's an x squared, there's a y, and then there's an x and an xy. So we're seeing kind of some that are similar, but they're not all consistent, where we could take a factor out of all of them. So what we're going to do is I'm going to rewrite this expression. I'm not going to change anything. I'm just going to reorder this 4x and this 6y. So now I'm going to write plus 4x plus 6y plus 3xy. And now what I want you to do is kind of group these variables together. So this one's going to represent group 1, and this is going to represent group 2. So if we were to look at group 1 only, and just start with group 1, let's see if there's a GCF, or a greatest common factor, of group 1. And what we can see is that there's a 2 and there's a 4 for the coefficients. So the GCF of that would be 2. You can write 2. And then, before I go to the bracket, there's also an x in both these terms, so we can factor out an x. And then we're going to be left with x plus 2. So just leave it like that for now, and now we're going to go into group 2 and do the same thing. So we're going to do plus, and we're going to do, okay, so what's the greatest common factor of group 2? Well, it's going to be a 3 for the coefficient, and then a y. So then it's going to be 2 plus x. And again, I'm going to rewrite this, but I'm not going to change anything, just to make it a bit more clear. We're going to have x plus 2 plus 3y, and then I'm just going to change the order of these two. So I'm just going to write x plus 2. So now, what we can tell by doing factor by grouping is that this entire term here is actually common to both the 3y and the 2x. So if we treat this x plus 2 as one term, it's going to be a common factor to both of them. Thus, we can do x plus 2, and then factor, basically take this, put it at the front of the bracket, put it at the front, and then we just have the remaining, so the 2x plus 3y. 2x plus 3y. And that would be the fully factored form using grouping. So now again, we took this expression up here where it didn't seem like we could factor a greatest common factor out, but we realized that once we had grouped them together, then we could factor out a common term because we were left with this x plus 2. So that was the easier version, and now we're going to go into a little bit of a harder version. So we're going to write 5m squared t minus 10m squared plus t squared minus 2t. So again, looking at this, we see that the coefficients we can definitely not factor out, right? Because the 5 and the 10 would work, but there's only a 1 for this t squared. So if we took out a 5, it wouldn't work, and similarly with this 2, it wouldn't work. So we have to look at factor by grouping again. And so what we're going to do is we're going to group these two together as group 1, and these two together as group 2. So looking at group 1, if we factor out the common factors for group 1, we have, well, 5 goes into both of them, right? 5m squared t and 10m squared. And then we're going to factor out an m squared because it's common to both of these. So then you can write t minus 2, right? Because we have 5m squared on the outside, and then we're left with just this t. But in here, since it's 10, we have to multiply it by 2, so it's going to be minus 2. And next we're going to do plus, and in this situation, the only common term, there actually isn't coefficients that are common, it's just going to be t on the outside. And then what we're going to be left with is t minus 2. And again, using factor by grouping, we now have this common term here, this t minus 2, that we can treat as one term and bring it to the front of the brackets. Go like that, and bring it to the front. Now we can rewrite this expression as t, not very good t minus 2 multiplied by 5m squared, which is just this number here, plus t. And then now that's a factored form of this above expression using factor by grouping. Okay, now we're going to go over onto trinomials. And we're first going to start with, I'll write trinomials where the a value is equal to 1. All right, a is equal to 1. So this is what a trinomial looks like. And so this a term, a is equal to 1. So the first problem we're going to look at is going to be x squared plus 5x plus 6. So the first step with any trinomial here, to factor it, is we're going to multiply this a term, which in this case is a equal to 1, multiplied by this c term. So this c is right there in this form. We have ax squared plus bx plus c. In this actual expression, with coefficients instead of just variables of b and c, we have x squared plus 5x plus 6. So what we're going to do is we're going to write 1 multiplied by 6. And that's going to give us 6. Now, I want to write the factors of 6. So we can write 1 and 6, because 1 times 6 gives us 6. We could also write 2 and 3, because 2 times 3 equals 6. And then now, we're going to check our factor tree here, and we're going to see which of the factors, if we were to add them together, sum to this middle term, or this middle coefficient. So looking at this, 1 plus 6 is going to be 7, and well, 2 plus 3 would work. So this is the factors we want. 2 plus 3 equals 5, and that 5 is what we're looking for over here. So now, once we've done this, we can now write the expression as x plus 2 multiplied by x plus 3. And that's the factored form. And if you look at what, to check if we're right, what we can do is just expand this out. So we can just expand this x and distribute these two brackets. So if I were to expand this out, it's going to be x times x, that's going to be x squared. And then x multiplied by 3, well, that's going to be 3x. Now we go into this 2, and we go 2 times x. Well, that's just going to be 2x. And then 2 times 3. That's going to be 6. And so here, if I collect like terms, the 2x plus 3x is going to be 5x. And now we check to see if we got it right. And as you can see, this form up here is exactly the same as this. So then we know that this factor actually worked, and we were correct. So the next case of this trinomial where a is also equal to 1, we are going to do, let's see, x squared plus 3x minus 28. So again, with trinomials, it's always kind of the same situation, the same procedure. So what we're going to do first, and so we're going to note that, okay, well we could write a 1 here. And that would mean that our a is equal to 1, right? Because 1 times x squared is just x squared. But we'll write that 1, and then what we're going to do is we're going to multiply this 1 by negative 28. So negative this time. So now we're going to have 1 times negative 28. That's going to be negative 28. And then we're going to do the factor tree again. So we're going to list all the factors of negative 28. So we're going to have 1 and 28. I'm going to write the absolute values, so just the positive values of this factor, but we're going to have to take into account this negative value here. So 1 and 28, let's see, 2 and 14, 3, I don't think 3 works, 4 and 7 works, and let's see, I think that's good for now. Okay, so in this situation, what we're looking for is we're going to do the same process. We're going to look for these factors, and their sum of these factors gives us this 3x. But we have to account for this negative value right here. So let's see. So what if we had, negative 1 plus 28? Well, that's just going to give us positive 27. And so that's definitely not plus 3x. What if we did, instead of that, we do 1 minus 28? So the 28 here is negative. Well, that's just going to be negative 27. That's definitely not 3, positive 3. Similarly, we can try 2 minus 14. And that's just going to give us negative 12. So what if we did negative 2 and positive 14? Well, that's just going to be positive 12. So that definitely doesn't sum to 3, which is what we're looking for. But we could do 7 minus 4. So that equals 3. And so this is kind of satisfying the second criteria. The first criteria was, okay, well we have 1 times negative 28. So the products of the factors of negative 28 have to equal negative 28. So we have negative 7 times 4, or sorry, it is actually 4, negative 4 times 7. That equals negative 28, which is what we were looking for. So that's good. And then also 7 minus 4, well that equals 3, and that's our middle term here. So what we can do now is we can now write this trinomial as x minus 4 times x plus 7. And again, we can kind of check our work by seeing if we expand this, if it actually gives us the right answer, or what we were trying to, it gives us the expanded form of what we're trying to factor. So we can do x times x, and then x times 7x, and negative 4x times 7. So we got x squared, and then plus 7x, minus 4x, and then minus 4 times 7, that's negative 28. If we collect these like terms, we're going to get x squared, and that's going to be plus 3x minus 28. And this is exactly the same as this up here. So we know that our factored form is correct. So that was trinomials where a equals to 1. Now we're going to go over to trinomials where a does not equal 1. So a does not equal 1. And they're still the form, obviously, of ax squared plus bx plus c. So for this example, we're going to go over, we'll go over 2x squared plus 5x plus 3. And like I said before, we're going to go through a very similar process. There's just one added step in the middle. So we're going to look at this, and we're going to see that this a is actually not equal to 1 now. It's equal to 2. But we're still going to do the same thing. We're going to do 2 times, so the a term here, times the c term. So it's going to be 2 multiplied by 3, and that's equal to 6. So once we have that equal to 6, we're going to list the factors of 6. So we're going to have 1 and 6, and 2 and 3. Now, we've satisfied that first criteria of a multiplied by c. Now we're going to satisfy the second criteria, where the sum of the factors is going to equal this 5 value. So in this case, everything's positive. So we're going to have positive values for all of them. And we're going to have, okay, well 1 plus 6, that's 7, that's not going to be 5. But 2 plus 3 works. 2 plus 3 is equal to 5. So here, if the trinomial was of the form where a is equal to 1, we'd be done. And we can just we could have written out the x plus 2 times x plus 3. But that's not going to be the case here because a is not equal to 1. If we were to kind of expand this out, it's going to be x squared plus, what is that going to be? 3x plus 2x is going to be 5x plus 6. That's definitely not equal to this expression up here. So what we have to do is account for the a value. And the way we do that is we separate this 5x term. We separate this 5x term, so 5x, into these factor components. So 2 plus 3 is obviously equal to 5. So I'm going to rewrite this as 2x squared. I'll just rewrite the whole thing right now, plus 3. We now know that we have this 2 and 3 satisfy this criteria. So what I'm going to do is I'm going to write 2x squared plus 2x plus 3x plus 3. So all I did there was I just decomposed. This is what's called decomposition. I decomposed this 5x into 2 separate terms. Now if I were to collect these like terms, obviously that's going to be 5x. So I didn't change anything in the expression. But now what we can do is we can use factor by grouping. So again, it's kind of another tool to use. It's like another step that's involved in this trinomial where a does not equal 1. So I'm going to group this group right here, and I'm going to group this group. So firstly, we'll go with group number 1, which is right here. So we're going to do 2x squared plus 2x. Well, 2x is common to both of those. So I'm going to write x plus 1. So that's group 1. Then I'm going to do, okay, well what's common to 3x and 3? Well, it's the coefficient 3. So 3 It's going to be on the outside, x plus 1. And again, we have this situation, just like in the factor by grouping examples, where this x plus 1 term is common. So we can pull it out of the bracket and factor it out and go x plus 1 is now equal to 2x plus 3. And so that is how we deal with trinomials where a does not equal 1. And that was kind of the easy version, and now we're going to go into kind of a little bit of a harder version. So what we're going to do is we have negative 2y squared plus 4y plus 48. So here, seeing that this negative is out front, what I'm going to do is I'm going to factor out the negative. So I'm going to write negative on the outside of this bracket, and I'm going to do 2y squared. It's going to be minus 4y minus 48. So the reason I did that was to get this term so this is positive. Just makes it a little bit easier, and we're just going to keep this negative on the outside. But if you were to distribute this negative in, it'd basically be like, this is like a 1 here, it'd basically be like negative 1 times 2y squared. Well, that's going to be negative 2y squared. And then negative multiplied by a negative 4y, that's going to give us a positive 4y. And then finally, negative multiplied by a negative 48, that's going to give us a positive 48. So it's the exact same expression, I just factored out that negative. So I'm going to erase this, just to kind of prove it to you that that all worked. So now we have this equation on the inside here. We have this 2y squared minus 4y minus 48. So this is a trinomial of where the form a does not equal to 1. So we're going to do the same thing though. It's 2 times this negative 48. So 2 multiplied by negative 48, that's going to give us, what is that, negative 96. Okay, so this is kind of a lot to deal with. Something kind of interesting here. It's a big number, it's going to take a long time to deal with all these factors. But what we could have done at the beginning, and I just kind of want to go through, what we could have done is instead of just factoring out this negative, or sorry, just this negative 2, or this negative 1, we could factor out a negative 2, because 2 is common to all these. So negative 2 times y squared, and then now this is going to be times negative 2y minus 24. And now, this turned into an example where this a term is actually equal to 1, because we factored out a greatest common factor, or a GCF, of negative 2. So now, what we can do is just go through our normal trinomial approach. So 1 times negative 24. Let's see, we're going to have 1 and 24. And I'm just going to write the absolute values, so meaning the only positive versions of the factors. But we're going to have to deal with this negative. We have to remember that is a negative. 1 and 24, there's 2 and 12, there's 4 and 6, and I think that's it. Yeah, we could write them in different orders, but I think that's gonna work. So now we've satisfied the first criteria, where our sums have to be negative 24. Now we need to satisfy the second criteria, where the products are equal to negative 24. Now we satisfy the second criteria, where the sums of these factors is going to be equal to negative 2. So if we were to look at all these, we would see that 4 and 6, well, if we had a negative 6 plus a positive 4, so I'll write in red, negative 6 plus a positive 4, that's going to equal to negative 2. And that's this value right here. Also, negative 6 multiplied by 4, well, that equals to negative 24, which is this value here. So we know that we've checked that out right there, and we can write this out. So we can write, so we're still going to have to keep this negative 2 out there, but we can now write it as negative 2 multiplied by, we're going to have x minus 6 multiplied by x plus 4. And that would be the fully factored form of this. So this trinomial that looked a little bit scary at the beginning, because we had this negative 2y, once we factored out a negative, and then factored out a greatest common factor, which was the 2, it actually turned out to be an example where a trinomial of a equal to 1. So always kind of look out for, a lot of these factor problems kind of combine different strategies, and you have to use all of them to get the fully factored form. So now we're going to move on to special patterns of factoring. And special patterns are very useful, and the first one we're going to go over is forms of, it's called a perfect square positive trinomial. So it's going to be PST positive. And PST is just perfect square trinomial. So it's of the form a plus b squared is equal to a squared plus 2ab plus b squared. And we're going to go over an example of this. So what we could do is we have this example, x squared plus 6x plus 9. So for all these examples, all these patterns, the trinomial example where a is equal to 1 or when a is not equal to 1 will work for these. It's just that the patterns actually help us solve these things faster. So what we're going to do is we kind of have this similar situation here, and we're going to kind of validate that the a term that we have and the b term that we have can, be, I guess, square rootable. Not really a word, but we're going to have an a term here and a b term. But we need to make sure that it gets satisfied by this 2ab. So if we were to just treat this as a trinomial, I would multiply this term a, which is 1, multiplied by this 9. We'd have 1 times 9. List out all the factors, see what adds up to 6x, and then go from there. But what's going to happen is we can look at this and say, okay, well, if our a term, if we say that, if we follow this pattern right here, if our a squared term is equal to x squared, then our a term is just going to equal to x, because the square root of x squared is just x. And then similarly, we're going to have our b squared is equal to 9. Let's just say it is right now. We're going to say this b squared. Let's just say it follows this pattern. We don't know if it does, but we're checking. Well, then b squared equal to 9. The square root of b and the square root of 9 is going to be 3. So I basically just want like this, and similar here, to the square root of them to get just an a term and not an a squared. And now what I'm going to check is, I'm going to check to see if our middle term here, so this 6x, if it matches 2ab. So we have our a term, which is x. So a is equal to x, and b is equal to 3. So now we just got to say, okay, well, a times x, we're going to do x, which is our a term, times 3, which is our b term, multiplied by 2. Because we're trying to see if it works and follows this pattern. So we're going to get 6x. 2 times 3 is 6, times x is x. So we have 6x. And that matches this value in here. So what we can do is we can write this, now that we know that our pattern of this x squared plus 6x plus 9 matches this a squared plus 2ab plus b squared, since this is an equation, we can just represent it as the other side of the equation, which is right here. So we can just write x, and we're going to write x plus 3 squared. And that is a fully factored form of x squared plus 6x plus 9. And to kind of prove it to you, I can write this as x plus 3 times x plus 3, because it's just something squared. And then I'll distribute in, and I'll kind of show you that, that was the wrong arrow. This x times this 3, and this 3x, and this 3 times 3. So it's going to be x times x squared, plus x times 3, 3x, plus 3x, because 3 times x, and then plus 9, because 3 times 3. So we're going to get x squared, collect like terms, 6x plus 9. That is our factored trinomial using a pattern. And the pattern was a plus b squared, or a plus b all squared, and it's going to equal a squared plus 2ab plus b squared. So now I'm going to go over a pattern where it's the perfect square trinomial negative. So I'm going to write PST, I'll do it in red, is negative. And this one is of the form a minus b squared equal to a squared minus 2ab plus b squared. And here, I'm going to look at this, the first problem we're going to get, and it's going to be x squared minus 8x plus 16. So again, we could do the trinomial approach, where we take this a term, which is 1, multiply it by this c term, which is 16. 1 times 16 is 16. Write the factors of 16, and see if we get the sum to be negative 8x. But what I want you to start doing is checking to see if the pattern works, and if it does, then we can skip all those steps and just jump to the final answer, which is going to be right here. So we're going to say that our a squared term is equal to x squared. And if we square root both sides, then we're going to get a is equal to x. So that works. And then we have our b squared term is equal to 16. So if we square root both sides, b is going to equal to 4. So that works, because they're both whole numbers that we square rooted, or that we got to, the result. Now we have our a term and our b term. We're going to look for this 2ab. That's right there. So 2ab. Well, it's going to be 2 times our a term, which is x, multiplied by b, which is 4. So we're going to get 8x. And now we know that our a squared and our a squared, our b squared, and our 2ab term all match this value right here. So again, we have this side of the equation, and since what an equation is saying is it's equal to the other side, now we can just write this as x minus 4 squared. So the only difference here was just that negative. Same exact approach, and then this negative here. But we saw that there was an a squared, which was our x squared, minus 2ab, which was our negative 8x, and then plus b squared, which is our 16. So now we can write it as x minus 4 squared. And finally, we're going to have, if I want to prove it to you, it would be x minus 4 multiplied by x minus 4. And if I distribute, it's going to be x squared minus 4x again. And then negative 4 times negative 4, that's going to give us positive 16. So then our final answer is going to, or I guess our expanded answer, is going to be x squared minus 8x, those two added together, plus 16. And that is the exact value we get up here. So we know that this factor worked. And again, this pattern basically just kind of saved us some time. We have to do a couple checks to see if the pattern actually matches. But by doing that, we don't have to do the factor tree, we don't have to do any of that, and we can kind of slowly start to see things a little bit faster and kind of make our life easier. So now we're going to go into the last pattern, which is differences of squares. So I'll write it in purple. Okay. So here we're going to have, the pattern is a squared minus b squared equal to a plus b times a minus b. And to kind of prove this, I guess, to myself and to you guys, it's going to be, if we distribute this out, it's going to be a squared. So I'm just doing this times this and this times this. So a squared, and then it's going to be minus, so a times negative b is going to be negative ab. And then we're going to have b times a, so plus b times a, and then minus b squared. So a and b, or a times b and b times a are the same thing. So these actually just cancel, because a negative, it's basically saying like a negative 1 plus a 1. So then we get to the final form of a squared minus b squared. So now, if we were to look at a problem where we had x squared minus 49, well, we're going to see if this pattern works. And this pattern is a little bit quicker than the other ones. So this pattern, we're going to look at, okay, well, let's just say our a squared term, which is right here, is equal to our x squared. And again, we'll check our b squared term, and that's just going to equal to our 49 here. So the square root of a and the square root of x, or square root of a squared is a, square root of x squared is x, and then the square root of b squared is b, and the square root of 49 is 7. So by just kind of validating that the a squared term and the b squared term were in fact square rootable, what we can do is we can write this x squared, I'll just rewrite it to show you the equation. We now know that one side of the equation, so this side, matches. So we can rewrite it as our a term, which in our case is just x, and then our b term, which here is just 7. So we're going to write plus 7 multiplied by x minus 7. And that would be the factored form. So on this side we have expanded, and on this side we have factored. And that is all the patterns we can use to help factor all of our expressions. So now I'm just going to go over a couple examples where we do kind of the combinations of everything. So it could be, you know, our positive square trinomial, or sorry, our perfect square trinomial that's positive, and a grouping example, or our difference of squares and a GCF. And so now we can kind of use all the tools we've learned through this video to solve any problem, or to factor any problem. So we're going to have, our first example is going to be 6axy plus 3bxy plus 6ay squared plus 3by squared. Okay, so if we were to look at this, the first kind of pattern, or I guess the first strategy we usually go with, is greatest common factor. So we see here there's any factors that could be factored out that are common to each of these. So what I see is, I see 6, 3, 6, and 3 for the coefficients. So I know that 3 is a factor of 6, and 3 is a factor of 3. So I'm going to write 3 as a greatest common factor. And then we have axy, bxy, ay squared, and by squared. So I'm actually going to take out a y because that seems common to all of them. So I'm going to write, so it's going to be 2ax, and it's going to be plus, and we took the 3 out, so it's just going to be bx, and then it's going to be plus 2ay, and plus, let's see, that's going to be by. Okay, so now that's good that we took the greatest common factor out. So we've kind of simplified this a little bit, but now what I'm going to do is I'm going to use factor by grouping, because I'm going to see that I'm going to group this one right here, so this is going to be group 1, and this is going to be group 2. It's going to be group 2. So looking at group 1 only, and we're going to have to take this 3y and, you know, remember it, so put it outside of the bracket here. So the greatest common factor in this group 1 is going to be, let's see, what is that? Looks like it's just going to be x. And then if I take that out, it's going to be 2a plus b. Okay. And then if I do group 2, I'm going to take out, it looks like it's just y. So I'm going to go y, and then take out 2a plus b. So now, like always with factor by grouping, we've now isolated a term that's common to both this y term and this x term. So if we bring the 2a plus b term out, we can write 3y times 2a plus b multiplied by x plus y. And that would be our fully factored form using greatest common factor, so I'll write GCF, and grouping. Okay, so that was our first combination. Our next combination is going to be using this expression, x squared minus 2x plus 1 minus 25z squared. Okay, so looking at this, what it's kind of looking pretty weird and interesting, but what I see is, this kind of looks like the form of a perfect square trinomial that's negative, right? Because there's that negative here. So this kind of looks like a squared minus 2ab plus b squared. So if we were to do that, we would say, okay, well, let's just say a squared is equal to x squared, and then the square root of a will be a, and the square root of x squared is going to be x. And next, we're going to have b squared is equal to 1, and the square root of b squared is just b, and the square root of 1 is just 1. Okay, now let's check our 2ab term. So our 2ab term is just going to be 2 multiplied by our a term, which is x, multiplied our b term, which is 1. So that's going to be 2x. So that matches here, matches at negative 2x. So now we know that if our pattern satisfied this part of the equation, it's going to satisfy the other part, which is going to be a minus b squared. So we can kind of skip all these steps and just factor this x squared minus 2x plus 1 as, let's see, it's going to be x, because that's our a term, minus, and then our b term is 1, and all that's going to be squared. So now we can we dealt with this part of the expression, and now we can look at the last part, which is negative 25z squared. And here, again, using patterns would be, oh sorry, this should be a 1, not a b. So using patterns is really helpful because that just saved us some time. And then here, if we look at this situation, I'm going to do it in purple, we have an a squared minus a b squared. We're just going to take this whole x minus 1 to be our a term because it's squared. So if we do that, we're going to have our a squared is equal to x minus 1 squared, and our square root of both sides, that's going to be x equal to, or a is equal to x minus 1, and then our b squared term is equal to 25z squared. So we square root both sides. That b is now going to turn into, well, the square root of 25 is 5, and the square root of z squared is just z. So now we've satisfied this part of the equation, and we could finish it off by saying this we know is equal to a plus b times a minus b. So now we finish the factoring by saying, okay, well, what's our a term? Well, our a term is x minus 1. So we'll put that in brackets. That's our a term right here. And then we're going to add our b term right here, which is 5z. And this is going to be big brackets because we already have this brackets in here. And we got to do the last bit of the equation, which is put in our a term again, which is x minus 1, and then minus our b term, which is 5z. And we're going to have that big bracket to finish. And that would be our fully factored form of this expression. So here is a situation where the patterns really helped us because we used the perfect square trinomial negative and we used the difference of squares pattern, and that gave us our final answer. So I know this is a long video, but thank you guys for watching, and I hope you got some value out of it. And let me know in the comments below what you want me to do for the next time.